All right, so you're here because you really want to understand what matters,
Nah.
right? I mean, you want to get to the heart of things and maybe even be a bit of an expert without wading through, tons and tons of information.
Exactly. And that's what today is all about. We're doing a deep dive into a pretty big meta-analysis looking at how computer technology impacts the way kids learn math, K through 12. I think a lot of people are curious about this.
I know I am. I mean, we see computers and tablets everywhere in schools these days. But the question is, does it actually help?
Right. Like, does all this tech actually make a difference in how well kids learn math? Well, luckily, there's been a bunch of research on this, and it's all been compiled in one place. So instead of looking at, just one study, we're seeing the big picture.
So this isn't just like someone's opinion in a blog post or something. This is based on a lot of research.
Yeah, for sure. This meta-analysis looked at 46 independent studies, and from those, they were able to pull out 85 different effect sizes, which is pretty impressive. And get this, over 36,000 students were involved in these studies. So we're not talking about a small sample size here.
Whoa, 36,000? That's a lot of kids. That's like a whole city of students.
Yeah, it is. So we can be pretty confident about the trends we're seeing.
So let's get to the big question. What's the main takeaway? Does having computers in the classroom actually make a difference?
Well, the overall finding is yes, computer technology does have a positive effect on how well kids learn math, a statistically significant one at that. They calculated something called Cohen's d, and it came out to an average of 0.28 standard deviations.
Okay, for those of us who don't speak statistics every day, what does that mean in real life? Like, what's a small positive effect look like in a classroom?
Right. So basically, students who use computer technology as part of learning math tend to do a bit better than those who don't. It's not a gigantic difference, but it is a consistent advantage. But there's a catch, and it's a big one.
Okay, I'm sensing a but coming.
But just having computers in a classroom isn't enough. Just plopping them down and hoping for the best, it doesn't really work that way. The technology is really just a tool.
Right, it's not some magic solution.
Mm.
So if it's not about just having the computers, what does matter? What are the things that make computer technology really have an impact on math learning?
That's where things get super interesting. The meta-analysis dug into all sorts of factors, and one of the first things they looked at was grade level. And here's a surprise. The positive effects were more noticeable for elementary school students than for those in middle or high school.
Really? That's unexpected. You'd think older kids with more complex math would benefit more from, fancy software. Why would younger kids see a bigger advantage?
It is interesting, isn't it? Now, the meta-analysis doesn't say exactly why this is, but we can make some guesses. Maybe the software for elementary math is just more engaging. It's often more visual and interactive and game-based. That might really help younger kids grasp those foundational concepts.
That makes sense. Now, what about students with special needs? Did technology impact them differently?
Here's where we see one of the most interesting findings, actually. Computer technology had a much bigger positive effect on the math achievement of students with special needs. Compared to their general education peers, the effect size was a huge 1.31 standard deviations.
Wow, that's a really big difference.
Uh,
Does the research give any examples of how this played out in the studies?
yeah, definitely. For example, they talk about a study from 1991 by Braden and colleagues that showed computer-assisted instruction was really helpful for hearing impaired elementary students. They did better on their math quizzes. There's also another study from 2002 by Irish, where multimedia software helped students with learning and cognitive disabilities understand math concepts.
So encouraging. Why might technology be so beneficial for students with special needs?
It probably comes down to a few things. Technology allows for a lot more individualized practice rate. It can be tailored to each student's pace and their needs. Also, using multimedia with visuals and audio and interactive elements helps students build mental models in different ways, which can be especially helpful for students who struggle with more traditional teaching methods. Plus, technology can help with collaboration and make learning more inclusive. Moreno and Mayer did some interesting research in 2000 on how multimedia can really help students understand concepts.
So technology can really help level the playing field and make learning more accessible for everyone. Now let's talk about the teaching side. Did it matter how teachers use the technology?
Oh, absolutely. That's another big takeaway. They found a much greater positive effect when computer technology was used with what's called a constructivist teaching approach. That's where learning is student-centered, and it's all about exploration and problem solving and asking questions,
Mm.
as opposed to a more traditional teacher-centered approach.
So what does that look like in practice? How is using technology in a constructivist classroom different?
Picture two classrooms both using the same math software. In a traditional setting, the teacher might use the software mostly for presenting information or having students do drills and practice problems on their own. It's kind of like a digital worksheet. But in a constructivist setting, students might use simulations or interactive tools to explore mathematical ideas, test hypotheses, and figure out solutions for themselves. They often work together too. The teacher is more of a guide than a lecturer. Connell's study in 1998 is a good example of this. He found that the same technology had different results depending on how it was used.
So it's not just about the technology itself, it's about how it's woven into the learning process. What about assessment? Did the types of tests used matter?
It's interesting. They found that studies using non-standardized tests like teacher-made quizzes or classroom assignments reported larger positive effects of technology compared to studies that use standardized tests.
So maybe technology is better at improving the specific skills and knowledge that are taught in the classroom, which are often what teacher-made tests focus on, rather than the broader skills measured by standardized tests.
Yeah, that's a good point. It could also mean we need to think about whether our standardized tests are really capturing the kinds of learning and problem solving that technology can help develop.
Makes you think, doesn't it? Okay, what about the amount of time spent using technology? Did longer interventions lead to better results?
Surprisingly, no. They actually found that shorter interventions, those lasting one term or less, showed larger positive effects compared to longer ones.
Really? I would have thought more time with a helpful tool would mean more benefit. What's going on there?
They think it might be something called the novelty effect. When you introduce something new, it's exciting and engaging. But as the technology becomes more routine, that initial excitement can wear off, and maybe its impact lessens over time. Kulik and others talked about this in 1982, and then again, Cosma brought it up in 2001.
The shiny new toy phenomenon, I get that. So what other factors did they look at?
They also looked at the unit of analysis. Basically, whether studies looked at data at the individual student level, the classroom level, or even bigger groups like whole grade levels or schools. And they found studies that didn't use the classroom as the main unit of analysis reported larger effects of technology.
So maybe when a whole school or district commits to using technology, it leads to better implementation and results.
Could be. They also noticed that studies published before 1999 tended to report larger effects than those published after 1999. And unpublished documents like conference papers sometimes showed larger effects than published theses or dissertations, which is something to keep in mind.
Right, because there could be a bias towards publishing the most positive results.
Exactly. And one last thing. They found that studies in developing countries reported larger positive effects of technology compared to those in developed countries. It'd be interesting to explore those reasons further.
That's a lot to consider. It shows that the relationship between technology and learning is really complex. Were there any factors that didn't make a difference?
Yeah, actually a few. Things like gender composition, racial composition, socioeconomic status of the students, those didn't seem to matter. And interestingly, the specific type of technology used didn't make a big difference either, whether it was tutorial software or communication tools or exploratory environments or general tools. The researchers also looked at the research design, whether it was an experiment or a quasi-experimental study, and that didn't significantly affect the results either.
So again, it seems like how technology is used matters more than what kind of technology it is.
Precisely.
So looking at everything we've talked about, what would you say are the ideal conditions for making the most of technology in math education?
From what we've seen, it seems like the best scenario is using technology with special needs students in elementary school and taking a constructivist approach to teaching where learning is active and student-centered.
Right, and the researchers even calculated that if you have all those positive conditions in place, you could see a gain of 2.03 standard deviations.
Which is massive.
Yeah, that's a huge potential impact. But it's important to remember that technology is just a tool. It can amplify good teaching, but it can't replace it, as Cosma said back in 2001.
Couldn't agree more. What we've learned today shows that the context really matters. Who are the learners? How is technology integrated into what they're learning? What teaching approaches are being used? Those are the things that determine how effective technology will be.
So to sum up what we've learned today, computer technology can be really valuable for helping K-12 students learn math. But its effectiveness depends on a lot of things. And the strongest positive effects are seen when it's used with elementary special needs students in a learning environment that's student-centered and focused on inquiry.
Well said. And this brings up a really interesting question for you, our listener. If the type of technology isn't the most important thing, then what is? What are the design principles behind the software and the implementation strategies that make technology so effective in those optimal conditions? especially for special needs learners and in those constructivist classrooms. What other questions does this raise for you about how technology is changing math education? There's so much more to explore, so we encourage you to check out the references from the meta-analysis or dive into some of the latest research.
Thanks for joining us on this deep dive. We hope this has been a helpful way to understand a lot of research and that you've learned some surprising and important things about the relationship between technology and math education. And as always, we'd love to hear your thoughts and any questions you might have. Until next time.
See that?